Hi, I'm Bob. Welcome to the 5 Minute Econometrics. Today, I will introduce the unbiasedness of the OLS estimators. Under 4 assumptions, the OLS estimators are unbiased estimators of the population parameters. That is, the expected value of the OLS estimator, beta hat, conditional on x equals the true parameter, beta. What are these 4 assumptions? The first assumption is linear in parameters. In the population model, the outcome variable y is related to the explanatory variable x and the unobserved random error term mu in a linear form. The key is that it is linear in parameters beta. Beta is what we want to estimate. The outcome variable y and the explanatory variable x are what we observed. They can take arbitrary functional forms such as logarithms or squares. The population model is also called the true relationship between x and y. The second assumption is random sampling. We have a random sample of n observations from the population. We use the sample to estimate the population parameters, beta. The random sampling assumption ensures that the sample is representative of the population. The third assumption is no perfect collinearity. There are no exact linear relationships along the explanatory variables. This assumption allows us to compute the estimators. In the case of simple regression, there is only one explanatory variable. The no perfect collinearity assumption is equivalent to the variation in the explanatory variable assumption for simple regression. If there's no variation in x, the explanatory variable will be perfectly collinear with the intercept. If an explanatory variable is an exact linear combination of the other explanatory variables, then the model suffers from perfect collinearity, and we cannot obtain the OLS estimates. The dummy variable chap is an example of perfect collinearity. Notice that this assumption does allow the explanatory variables to be correlated. We know that the purpose of including control variables in the model is that they are correlated with the key explanatory variable, and we want to hold the controls fixed in the analysis. They just cannot be perfectly correlated. The fourth assumption is the zero conditional mean assumption. The error term mu has an expected value of 0, given any values of the explanatory variable x. First, it contains the mean independent assumption. The mean of the unobserved error term does not depend on the values of the explanatory variables x. Since it is always true that the population mean of the error term is 0, as long as there is an intercept in the model, we can combine them into the zero conditional mean assumption. The key is the mean independent part. It ensures the unbiasedness of the OLS estimators. The assumption fails if an unobserved factor in the error term is correlated with the explanatory variable x. We call it omitted variable bias. If the model suffers from omitted variable bias, the OLS estimators will no longer be unbiased. The zero conditional mean assumption plays a central role in the OLS analysis. Under assumptions 1 to 4, we can mathematically show that OLS estimators are unbiased. We use the matrix notations to prove it. We can also verify the unbiasedness of OLS estimates in Stata. We generate random numbers for the explanatory variable x and the error term mu through the data generating process. We set the seed to guarantee the result can be replicated later. Then we generate the outcome variable y, which follows a true relationship we assume y equals 6 plus 4 times x plus mu. Now we have simulated the explanatory variable x and the outcome variable y. Since we know the true relationship between them, we can verify whether the OLS estimators are unbiased. That is, the estimates are close enough to the true parameters. We regress y on x and find that the intercept and slope estimates are very close to the true parameters we set. If we increase the number of observations or repeat the OLS regression many times and obtain the average estimates, the results are even better. Thank you very much for watching the 5 Minute Econometrics. See you soon. Thank you for watching this video and subscribing to my YouTube channel. See you next time.